Welcome to the Engineering Insights podcast, presented by Haystack Analytics. I'm your host, Junaid Ali. In this podcast, we hope to present views and interviews for software engineering leaders. I'm joined today by Julian Colina, CEO of Haystack Analytics, who will be giving us a primer on engineering metrics. Hi, Julian. Thank you for joining me on this podcast. So I think a good area for us to kick things off is if you could tell us a little bit about the story which led you to being a co-founder of Haystack and why you kind of really wanted to enter this space.
Yeah, that's a great question. So it might help to touch a little bit on my background as well as my co-founder Khan. We're both engineers, eventually tech leads. I was the director for my last company. Helped scale my company from nothing to hundreds of millions of users, and Khan has a pretty similar background working over at Cloudflare. And that gave us a pretty unique opportunity to actually advise other CTOs. And at the time, we were actually roommates in Singapore, funny enough. And over dinner once, we were sort of talking about some of the problems that our clients were running into. And it dawned on us that these were all the same problems that we sort of all ran into, both our clients and us in past lives. And what we really realized was that engineering leaders lack visibility. And it makes it really hard to understand even simple questions that we were getting asked, like, are we getting better over time? Are we more efficient? Where can we improve? These seemingly simple questions were incredibly difficult to answer for engineering leaders. And when we looked around for a solution, we really weren't too happy with what we saw. We saw a lot of companies trying to measure things like lines of code, hours worked, even number of commits, and quite literally ranking engineers based on these metrics. And we thought that was fundamentally the wrong approach. So, we started to build Haystack with a really simple goal. Can we build engineering analytics to give engineering leaders visibility into how their teams are performing in a way that truly helps the team? And that's sort of how we got to Haystack today.
Awesome. So I guess what it'd be useful to drive into a bit about what you mean by being an engineering analytics company. I mean, there's lots of different things people think about when they think about different types of analytics organizations, and lots of people when they work with engineering teams don't really measure what they're doing. So, could you talk about what it really means to be an engineering analytics company?
Yeah, so that's exactly correct. We work with engineering analytics, which can be seen as sort of a vague term. But really what we do is we use data from GitHub to help teams understand very specifically their delivery funnel at a team level. So we help them get really good at delivering software by understanding some of the fundamental metrics that make an engineering team successful. And we can talk about some of those specific metrics later, but from a high level, what we do is help you visualize trends across teams like speed and quality, plus dive into every aspect of that delivery funnel. So things like development time, even code review to help uncover bottlenecks like how long does it take to respond to a pull request? How long do we spend reworking code when it's in the review phase? All the way to things like large pull requests that are holding up delivery. So you can imagine as features go through our delivery funnel, they often get stuck at various friction points, let's say within QA or deployment. And we help uncover those friction points, letting teams identify them, first of all, measure their impact, and then have a really, really nice measurable way of understanding if they're making changes to improve on their process or include automation. Is that really driving an impact?
Awesome. So I guess part of this is, some people will be out there thinking, if they've got an engineering team in their organization, that they could be delivering things really, really well from a product standpoint. They they're in a good position. They feel they're building something which is phenomenal. But why is it actually important to measure engineering performance specifically? I mean, how does that engineering performance really tie in with the broader organizational goals, and why is it important to measure that?
Yeah, that's a great question. And if you find yourself in the position where you're building a great product, you're moving quickly, everybody's happy, then that's fantastic. I think that's what we all strive for. But looking at some of the best engineering teams in the world, they're constantly improving, and there's really no stopping the improvement that you can get from an engineering perspective. And there's been some excellent research actually in the space across thousands of companies. What the benefits are to the company when an engineering team is truly performant and efficient and able to deliver high quality code, high quality features quickly to customers. And it basically correlates to higher levels of profitability, market share, and customer satisfaction, which really makes sense when you think about shipping software is a company's heartbeat, right? The ability to provide value to customers quickly, to innovate, to build something that people want, as Y Combinator likes to say. And if you're able to do these things successfully as an engineering team, you really do help drive the success of the organization. And I would urge anybody listening to actually read Accelerate, which is a great book which touches on a lot of this research that shows the correlation between engineering performance and business outcomes, which is historically something that's a bit difficult to actually to measure and to understand. One quote that I like to use is from Mark Andreessen, which states, "Cycle time compression is the most underestimated factors in determining winners and losers in tech." And that makes a ton of sense, because when you think about it, actually decreasing cycle time helps us get value to customers faster. It helps get feedback on whether we're building the right thing faster, and ultimately helps us innovate on what we're building even faster. So all these things really help drive company performance overall. But that's not the only thing that we're able to achieve when we're actually focusing on engineering performance. There's actually a ton of benefits for the engineers themselves as well. There's a ton of common friction points that end up becoming very clear when you're focused on these sort of North Star performance metrics. Things like context switching, technical debt, distracting meeting. I mean, the list goes on and on. But when you can actually visualize these metrics, these North Star metrics like speed and quality, then it becomes very easy to advocate for changes and actually improve that developer experience when you can see things like context switching or technical debt having a dramatic impact on your end delivery, which often it does. So at the end of the day, measuring performance has a ton of benefits, not only to the organization, but to the actual developer experience itself.
Awesome. So you kind of touched on cycle time there, which I guess we can drill into a bit later. But cycle time is something we often consider as a North Star metric, right? It's something which measures the end-to-end performance of an engineering organization. But that's not the only thing that we like to measure. We have these leading indicators. We have short-term risk factors, which are important things to measure as well. And um, so we've got this kind of split between North Star metrics, leading indicators, and risk factors. Could you talk a bit about why each of these are important and the different role they play for measuring engineering performance?
Yeah, sure. That's a great question, and I think it's important to really dissect the difference between a North Star metric and something like a leading indicator or a risk factor. So a North Star metric really helps align your team around what matters to the engineering department. And the first question always is, what actually matters? And through reading nearly every piece of research in the space, talking to thousands of engineering leaders, we've sort of boiled it down into one simple sentence: the number of successful iterations. And what that really means is how frequently can we deploy value to customers? And that's a combination of speed and quality. So it's how frequently, how quickly can we deliver quality code to customers? And the way that we measure some of these things, just to touch on it really quickly, is cycle time, deployment frequency, change failure rate. And those are really what encompass a North Star metric, this balance of speed and quality. And often the next question that comes along is, doesn't it matter more what you're building rather than how fast you're building it? And ultimately, the question is obviously yes. But the way that I use, the analogy that I use to sort of answer that question is, you can think about engineering as a race car. Our job is to really move as fast as we can safely. And lucky for us, we also have the backing and support of a product team to help us make sure that we're actually driving that race car in the right direction. And the way that the engineering team can actually support building the right thing is to make sure that we can go through fast feedback loops, make sure we can get value to customers quickly, get feedback quickly, and iterate on our product, making it easier to actually build the right thing. So these North Star metrics really help align your team around that fundamental concept of number of successful iterations. And that helps you quickly identify when there's an opportunity to improve and really get good at delivery, being able to identify when problems arise quickly and being able to advocate for change using these North Star metrics. Now, to touch really quickly on leading indicators or risk factors, these are sort of sub-metrics that help drive those North Star metrics. So again, North Star metrics being speed and quality, there's some things that directly impact those. Those are things like pull request size or first response time. They're not great metrics on their own. Definitely, we shouldn't use something like a PR size as a KPI, but when you use them to actually drive those North Star metrics, it's very effective. So these North Star metrics, when you're using them in combination with some of these leading indicators or risk factors, we've seen teams really drive incredible improvements. We've seen delivery speeds up to 90%, decreasing the amount of defects in production, and that's really the power of using these North Star metrics if you're using the right ones.
Awesome. And I guess, yeah, I think it is really important to, get those measures really spot on, because one of the worst things you can do is you can be measuring something which ends up, making your performance worse if you're measuring something like lines of code changed, or a, meaningless metric that just draws down performance. So I guess in terms of validating these North Star indicators, there are some third-party references we've mentioned earlier, Accelerate, and then you and Khan, when you were kind of founding Haystack, did a lot of your own kind of market research. I'm wondering if you could really summarize that, both the third-party kind of research and the kind of novel research that you did when you were founding Haystack as well.
Yeah, that's a great question. So being an analytics company, we're obviously very data driven. So we sort of dive into every research we can find. We do a ton of research on our own as well. We have a ton of data to sort of parse through and analyze. So out of that comes a ton of interesting insights into what actually helps engineering teams become more performant, efficient, and how does that really impact the business. So Accelerate, the State of DevOps report, two great pieces of research that are done across thousands of organizations over many, many years. And they really show that the teams who can excel at the North Star metrics that we track, so again, that's cycle time, deployment frequency, change failure rate, when you're able to excel at these particular metrics, it's highly correlated to organizations with higher levels of profitability, market share, and customer satisfaction, which again, going back to Mark Andreessen's quote about cycle time, if you're able to get really good at delivering quickly, high quality value to customers, then that will inevitably start impacting your ability to innovate, which will, impact profitability, market share, customer satisfaction, and these types of things. So it's about a 200-page book, I think. So there's a ton to actually dive into, but I think that's the main takeaway from there. These metrics and engineering performance as a whole truly does impact the organization in a meaningful way. And when it comes to Haystack doing its own research, I think every metric in Haystack has gone through a pretty rigorous process to make sure that it's actually effective. So we're constantly analyzing data across hundreds of thousands of pull requests, finding patterns in things like pull request size, context switching, working hours. So we really do the homework for you, making sure that every metric that we're looking at actually drives an impact. There's actually a few pretty exciting pieces of research coming out pretty soon around what is the impact of context switching, what is the optimal pull request size. So pretty excited to release that. Shout out to Horn, who put in a ton of work into that piece of research. But ultimately, the entire mission of Haystack is to help you get really good at delivering software. So we put a ton of effort into making sure that there's no fluff, and that every metric and insight that we're providing actually helps move the needle and make the engineering team better. One of the funny things when it comes to sort of validation is sometimes we get people trying out Haystack that want to do things that fit outside what has been validated. And some of these things are wanting to measure or compare individual engineers. And time again, that research shows that it's an ineffective approach to measuring performance. So we don't have anything like that in Haystack, obviously, and we actively turn customers away. We make a strong effort to make sure everything in Haystack aligns with the leading research and best practice. So to sort of summarize between Accelerate and Haystack's own research, everything in Haystack is research-backed. And if anybody has questions or want to look through some of those reference points, feel free to email me at julian@usehaystack.io. I love talking about this stuff. Can share whatever, all the research that we've found so far.
Awesome. Yeah, that definitely makes sense. And the four key metrics that we saw in Accelerate, we have two which are traditionally based around, reliability, change failure rate, and mean time to recovery. We've got number of deployments there, and then we've got cycle time. And cycle time, it's often described as particularly important as a, North Star metric for engineering team. It's often something that's overlooked. And, often, as engineers, we can say, okay, we want to get things as reliable as possible, or we want to up the amount of deployments to get us in terms of, DevOps best practice. But cycle time is something which is often overlooked, but often, ties together a lot of these different factors and how good an organization is. So I'm wondering if you could really walk us through as to why it is such a particularly important metric to look at.
Yeah, cycle time is a pretty incredible metric, actually, because it has a lot of benefits that I'd say most people don't realize. But put simply, just to define cycle time for everybody listening, you can think about it as how we can measure how quickly we're able to deliver any given feature. And when it comes to faster cycle times, quicker cycle times, it has a ton of benefits. One, like I keep mentioning, the faster feedback loop, both for engineers to get feedback on their work, but also when we deliver that value to customers, it's a fast feedback loop to make sure that we're in the right direction. Then when we decrease cycle time, it's also a forcing function to properly scope our work. So when you're focused on cycle time, the work ends up being smaller. We put more effort into design and properly scoping, which makes it easier to review, less prone to error. When we focus on cycle time and faster cycle times, it actually allows our organization to be more agile. There's less cost to shifting priorities. So you can handle incoming business needs more effectively, and it actually produces less context switching as there's no long-standing work in progress. So ultimately, faster cycle times leads to faster delivery, obviously, but more importantly, even higher quality releases, an increased level of predictability, and more agility to actually handle the business needs. Again, I love this quote: cycle time compression is the most underestimated factor in determining winners and losers in tech, and there is so many reasons for that.
Excellent. So, there'll be a lot of people, when they hear about cycle time, the first thing they'll really ask after that is how can my team actually go about, meaningfully reducing the cycle time? Okay, we've got the metric, we've been able to measure it. What do we do next? How do we actually go about, making a meaningful dent in cutting that metric down?
That's a great question, and Haystack can help with that, obviously. But it's 100% possible for any team to decrease cycle time. So a lot of times teams come to us and say, "Oh, we have these large pieces of work or these small pieces of work, or what we're working on is fairly unique." And at this point, we've worked with so many different companies and so many different industries that it truly is possible, we've realized, for any engineering department to reduce their cycle time and improve on it. And what it comes down to is there's many, many levers to actually improving cycle time. And that part is actually team dependent, whether it's process changes, etiquette around your code review, reducing pull request size, introducing automation, restructuring teams, that list goes on and on. The more important thing is to establish a culture of continuous improvement, to be able to actually measure cycle time first and foremost. That way you can identify bottlenecks that are impacting that cycle time. Let's say you have an outlier one week, or one particular piece of work has a very high cycle time. What that gives you is one reference point where you can start to understand, okay, why did this piece of work, why was it different from the rest? Was it stuck in QA? Was it a huge pull request? Did it touch on some aspects of technical debt within the system? And when the whole team is sort of rallied around this one metric, cycle time, you can start to track the impact of your changes. So let's say you measure cycle time, you identify an outlier, you find what that bottleneck might be, and then you make an active change to improve on that for the next sprint or the next week. Then when you come back, you can actually see the impact of that change. So in the same way that we build, measure, learn to improve our product, we should be doing the same for our process itself. We should measure, we should identify bottlenecks, and then we should see the change, the impact of the changes that we're making. And that's what we help you do at Haystack. But even without Haystack, if you can get to the point of establishing a culture of continuous improvement, then you'll be able to reduce cycle time by simply implementing this whole measure, identify bottlenecks, and track the impact of those changes.
Awesome. And I realize we're coming up to 20 minutes, and we've spoken about a lot of things without mentioning any buzzwords about data science or machine learning. So I think that's always a good sign there. So I guess to wrap things up, I mean, where should people go to really learn more about Haystack and a lot of the upcoming kind of, you mentioned some of the research work Horan's work on, and some of the content we're producing, and more critically, the people who really need a tool to measure these metrics. How do they go about, working with Haystack?
Yeah, that's a great question. So the first stopping point is probably our website. So usehaystack.io. And in there, you'll find a whole bunch of documentation, blogs, our podcast, as well as some research papers that we've published as well. So that's a great stopping point if you want to read more about Haystack or any of the research, or even how to implement any of the practices that I've described today. There's a ton of great content on the blog itself. If you want a more sort of active approach to learning, then you can subscribe. So on our blog, there's a nice subscribe button where we'll sort of feed you insights week over week. And if you want to reach out to me, I read every single email in my inbox. So Julian@usehaystack.io. Happy to chat about any of this stuff if you have any questions or want to dive into some of the things that your team might be facing today. Happy to do that too.
Excellent. Well, thank you so much for taking the time. I think it's been really valuable, and it's great to get to be able to record some of your thoughts on these things. So I'm really grateful for you taking the time today to speak to me.
Awesome. Thanks for having me. It's fun.
Thank you for joining me for this episode of the Engineering Insights podcast, where I've been joined remotely by Julian Colina. We hope you'll join us next time for more resources for engineering managers and DevOps leaders. The soundtrack used in this podcast has been Werq, spelt W-E-R-Q, by Kevin MacLeod. This podcast has been recorded and produced in Edinburgh, Scotland for Haystack Analytics.